Bismillahirrahmanirrahim. Assalamu alaikum, dear students. My name is Abbas Jafri from Asas National School, Senior Boys Campus, Rawali Kent, Gujranwala. Since I have been teaching you the subject chemistry and we are studying chapter number 9, Chemical Equilibrium. Today is our lecture number 9. In the previous lecture, we did the examples of expression of equilibrium constant derivation. We did test yourself 9.2 and we saw that equilibrium constant Kc definition and whatever it has units or not. So in today's lecture we continue the topic of equilibrium constant Kc and its units. We will solve the numerical problems to calculate the value of equilibrium constant Kc, and the problems are problem number 9.1, 9.2 and 9.3. So our first topic is equilibrium constant Kc and its units. We have discussed this chapter in the last lecture, so we revise it in deeply in today's lecture. So equilibrium constant is a ratio of the product of concentration of products raised to the power of their coefficient to the product of concentration of reactant raised to the power of coefficient as expressed in balanced chemical equation. So dear students, you can see that equation shows that on numerator there are the products and in the denominator there are the reactants. Raised toward the power means the value of their coefficient in balanced chemical equation. So you can easily say that on the denominator the product of concentration of products, or multiplying the concentration of product raised to the power of their coefficient, and in the denominator the product of concentration of reactants. So we can say that Kc is equal to product concentration over reactant concentration. So it is conventional, or it is used to write the product as a numerator and reactants as denominator. So dear students, we can calculate the numerical value or the number value of Kc by putting actual equilibrium concentration of the reactants and the product into an equilibrium constant expression. So we can find the values. So the value of Kc depends only temperature. It does not depend upon initial concentration of the reactant and products. It means that when equilibrium establishes in a reversible reaction, so concentrations remains constant. So value of Kc does not depend upon the concentrations. A few problems have been solved to make the concept clear. There are the many scenarios Kc may have units or may not have units. So in the first case, Kc has no units. Kc has no units in reactants with equal number of moles on both sides of the equation. So this is because when concentration cancel out in the expression for Kc. For example, H2 plus I2 is equal to 2Hi. It's a reversible reaction. So in this reaction you can see when we write the Kc, so Kc is equal to concentration of products over the concentration of reactant raised to their power of coefficient. So Kc is equal to Hi over Hi square over H2 over I2. So its units are, so in numerator the product have units raised to the power 2, and in numerator both of the two reactants combine to form raised to the power 2 also. So these two units on numerator and denominator cancel out each other. So in this case Kc has no unit. And in another scenario Kc have units because in reactions the number of moles of reactants and product are not equal in the balanced chemical equation. For example, the reaction, the formation of ammonia, NH2 plus 3H2 is equal to 2NH3, in which Kc, the balance of numerator and denominator units is different. In numerator, Ni3, which is a product, have the value of units raised to the power 2. But in numerator, the reactants has raised to the power 4. You can clearly see in this video that products have raised to the power 2, units of product have raised to the power 2, and units of reactant has raised to the power 4. So we subtract the power of numerator from denominator, that comes to minus 2. So you can see that minus 2 is a whole power of mole and decimeter cube. So we can multiply minus 2 into mole, that is mole minus 2, and multiply dm to minus 2, that is equal to minus 3 multiplied by minus 2, that is equal to plus 6. So the units are mole minus 2 dm 6. So dear students, we found out the relation of equilibrium constant. So we try to solve few numerical problems from our textbook and calculate the value of equilibrium constant Kc. So dear student, this is a problem number 9.1, which is an example from your textbook. When hydrogen reacts with iodine at 25 centigrade to form hydrogen iodide. So you can see from this equation that two reactants, hydrogen and iodine, H2 and I2, react to form hydrogen iodide Hi by a reversible reaction as follows. So the concentration are 0.05 mole per decimeter cube, iodine 0.06, and Hi is 0.49 mole per decimeter cube. So we calculate the Kc expression for this reaction. So dear students, let's solve out this numerical problem, which is very simple and very easy. Dear students, you should keep in mind, you should understand that in your textbook, the balanced chemical equation are given. So, but when the question is asked in the board exams, the balanced chemical equation is not given. The data is given in very short form to solve the numerical. So in the examination, no balanced chemical equation is given. So you have to solve the questions to keep in mind that balanced chemical equation is to be extract from the numerical statement. So it is not given in the board examination. So H2 and I2 form 2Hi, which is a reversible reaction. So the expression of the value of molar concentrations are prescribed again. So the Kc, we have to find out the Kc. So the Kc is equal to the product of molar concentration of product raised to the power of their coefficient, or the product of molar concentration of reactants. So Hi square over H2I2. So we put the values of H2, Hi, which is equal to 0.49, and H2 is 0.05, and I2 is equal to 0.06. Then dear students, we have to multiply these equations. So in the sidebar you can see that the mathematical work is done. 0.49 twice is equal to 0.204, 0.2401, and 0.05 multiplied by 0.06 is equal to 0.0030. So we put these values in expression, that is equal to 0.204, which is a square of 0.49 over 0.0030. So we divide this Kc value again in sidebar, that is answer is 80. So the value of Kc is 80. So we have find out the value of equilibrium constant of this reaction, and that is 80, and it do not has unit, because when you say that calculation of units, then units are cancel out each other. So this Kc value has no units. Dear students, for your understanding, I solved out the calculation of units of Kc. So it is not necessary to write this calculation of units of Kc in your test or in your proper exam. So you can find out the units by just judging the uh, coefficients of the judging the powers and find out the units in rough side or in rough area. So dear students, here is another problem 9.2. For the formation of ammonia by Haber process, hydrogen and nitrogen react reversibly at 500 Celsius, and the chemical balance chemical equation is written: N2 plus 3H2 is equal to 2NH3. So the equilibrium concentration of these gases are given, then nitrogen, hydrogen and ammonia concentrations. So again in this numerical, we have to find out the value of Kc. So dear students, be careful and keep in mind that it is very similar numerical like the previous one. So you can see it with great care. So you can see this is a balanced chemical equation. Again, I remember you that balanced chemical equation will be not given in the board exam. So you have to write it on your own by extracting the data from the value. So N2 is equal to 0.602, H2 is equal to 0.420 and ammonia has a value 0.113. So Kc equation like the previous one, our products are in numerator and reactants are in denominator. So you have to put the values of ammonia and nitrogen and hydrogen, and then we calculate the values of Kc, and some calculations are done in the sidebar. The square of 0.113, that is equal to 0.012769, and is rounded to 0.128, and 0.420, the cube of 0.420 is 0.0740, so it rounded to 0.741. So the Kc value is equal to 0.26286 mole minus 2 dm the 6. So dear students, you can say that this Kc value has units. So we have discussed these cases earlier, sir, case calculation of units. So again we calculate the units for Kc for you, dear students. So on the product side, the power is 2 and the combined power of reactant side is 4. So we again divide the power from product over reactant, that is 2 minus 4, and that is equal to minus 2. So multiply minus 2 into mole and then multiply minus 2 into decimeter cube minus. So the value is equal to mole minus 2 and dm the power 6, which is the unit of this Kc. So no need to write this calculation in the numerical, but it has to do it manually on your own and write the unit of mole minus 2 and dm 6 in front of Kc answer. So the problem number 9.3. So you can see that this is the narration of problem number 3 and you don't have any chemical equation written here, no balanced chemical equation. So you can see that we clearly say that PCl3 and Cl2 are reactants and they form PCl5. So we can easily draw the balanced chemical equation for this reversible reaction. So dear students, just for read the this numerical, you can see that the equilibrium constant has a value 0.13 mole inverse dm cube. So it is a unit is just changed because of the calculation of units. So the value of Cl2 and the value of PCl3 are given and the value of Kc is given. So we find out the value of PCl5, which is the concentration of product. So here something is different in this numerical. So we have to write PCl3 plus Cl2 is equal to PCl5, which is a balanced chemical equation. We have to write in first. Then after that, the given concentrations of PCl3, Cl2 and Kc, and we have to find out the concentration of PCl5, molar concentration of PCl5. So write out the expression of Kc, concentration of product over concentration of reactants, and then Kc value is 0.13 and PCl3 has 10 value and Cl2 has 9 value. So just very simple, we calculate the numbers in sidebar and the answer is 11.7. So the concentration of PCl3 is 11.7. Dear students, when we have to find out the molar concentration of reactant or the products, जब हमने प्रोडक्ट और रिएक्टेंट्स को फाइंड करना हो तो हमें सिंपली मोल पर डी एम क्यूब उसका यूनिट लिख देना है. वी हैव टू राइट आउट द यूनिट ऑफ मोल पर डी एम क्यूब. के सी में हमने ये फाइंड करना है, यूनिट को चेक करना है, बट इन द केस ऑफ रिएक्टेंट और प्रोडक्ट हमने अगर फाइंड करनी है तो हमने बड़े सिंपली मोल पर डी एम क्यूब उसका यूनिट लिख देना है. Dear students, it's over for today now. So in the end of this lecture, I have an assignment for you to learn and practice, which is very simple. So write down the definition of equilibrium constant and tell when Kc has units and when it does not. So solve and practice numerical problems 9.1, 9.2 and 9.3. So dear students, this is a very simple message from me to you that you have to give a special concentration on the syllabus of 10th class because it is decided by the board authorities that the marks of 9th class will be given on the result of the 10th class. So you have to be focused on your 10th class result from today. Okay dear students, stay home, stay safe. Thank you very much. Allah Hafiz.